Hello guys, welcome to my channel Indian Pharmacy Education. Myself Shiva. Today we are going to start the lecture videos of pharmaceutics, M for pharmaceutics. Firstly, we are going to start with the UV spectroscopy as we discussed the syllabus, entire syllabus in the last video. Today we are going to start with the UV spectroscopy. Firstly, the syllabus in UV spectroscopy are that we are going to discuss are introduction, theory, laws, instrumentation uh, associated with the UV spectroscopy, choice of solvent, solvent effect, and applications of the UV spectroscopy. The main questions asked are the laws and instrumentation. These two topics are very important. In this topic, the Beard-Lambert's law is present, so it is very important. You can see the questions asked from the previous year papers. These are the questions asked. Mainly, they have asked the Beard's law. They have asked, and they have asked instrumentation, about the instrumentation, and they have asked one more question which is not mentioned in the syllabus, that is uh, explain the Woodward's rule. This Woodward's rule is not mentioned in the syllabus, but they were asked twice. They were asked twice what is the discuss the importance, calculation of Woodward's rule, and their rules. They were asked rules mean how to calculate the lambda max for any particular structure or organic compounds or conjugated compounds, how we should calculate the lambda max. They've asked. These are the main questions asked in the previous year questions. You can see the main topic you have to cover first are uh, the theory and laws you have to cover, and the instrumentation. These are the main topics you have to cover in this topic. Let's move on to basics. Introduction to spectroscopy. Spectroscopy deals with the study of interactions of electromagnetic radiation with matter. Here we can study the interactions of electromagnetic radiation and matter. What are the interactions going on between these two is called a spectroscopy. It is a simple definition. Okay. Next, the definition of spectroscopy. Spectroscopy involves the measurement and interpretation of electromagnetic radiation, whether observed or emitted, when the molecule or atom or ion of the sample moves from one energy state to the another energy state. Here we can see the energy is observed by the molecule or atom or ion. It causes excitation from lower state to higher state. This is called excitation. And emission, here emission is refers to the energy is removed. Here energy is absorbed, energy is removed. That's the difference between absorption and emission. After absorption, then the lower state goes to the higher state or excited state. Here after emission, the energy is removed. Here it comes from the excited state to the ground state. That's the main difference between them. Here the energy of the molecule. How can you define energy of molecule? We should uh, we should calculate the sum of rotational energy, vibrational energy, and electrical energy. The sum of these three energies we call as the energy of the molecule. Next, electromagnetic radiation. First, we have to know the basic what is mean by EMR. It is the fundamental uh, principle involved in every spectroscopy. Without electromagnetic radiation, spectroscopy is nothing. With using of electromagnetic radiation, we are going to study the interactions of the matter and the sample and the light. It is a form of energy consisting of wave of electromagnetic radiation. It consists of both electro and magnetic. These two are perpendicular to each other and they travel at same velocity in vacuum. You can see this is the diagram. Here electromagnetic radiation, and this is the direction of propagation and electric field. This is the path of the waves that this travel. It's just a diagram. You can just refer Another diagram. This is a basic diagram and this is the basic concept of electromagnetic radiation. Next we are going to study about the fundamental units. What are the fundamental units of the spectroscopy? First, the wavelength. It is the distance between two adjacent crust or thrust in a particular wave, expressed in a nanometer, angstrom and micron. You can see this is a diagram. It is the distance between one peak or two peaks of the wave or two dips of the wave. You can say crust and thrust. Next, wave number. Wave number is nothing but the number of waves per unit length or per wave per centimeter. Wave number is defined as the number of waves per unit length per wave per centimeter. It is expressed in centimeter inverse or Kaiser. This is the formula and this is the diagram. Next, frequency. Frequency is nothing but number of oscillations of the field per second, expressed cycle per centimeter or hertz or Fresnel. Let's continue with this topic. Uh, ultraviolet and visible spectroscopy deals with the recording of absorption of radiation in UV and visible regions of electromagnetic radiation. As I said, here only the absorptions of the radiations in UV and visible regions are recorded in the UV spectroscopy. Their UV region is extended from 0 to 4 nanometer, which is subdivided into near UV it is 200 to 400 nanometer, and far or vacuum region 10 to 200 nanometer, and the visible region extends from the 400 to 800 nanometer. Next, organic chemist. What is the main function? What is the main importance of this UV visible spectroscopy? Organic chemists use UV and visible spectroscopy for detecting the presence and elucidating or explaining. Elucidating refers to explaining the nature of conjugated multiple bonds or aromatic rings. It is the main purpose or main importance of the UV visible spectroscopy. Let's go on to the theory of UV visible spectroscopy. Next, the ultraviolet absorption spectroscopy rises from transition of electrons within a molecule or ion from lower state to the higher electronic energy levels. Here the basic, or else a principle or basic interaction occurs when the molecule absorbs the energy and moves from the lower energy state to the higher energy state, lower to higher electronic energy level. I'll explain in the next coming topics. Ultraviolet emission spectroscopy rises from the reverse of this type of transition. I'll explain you. I have already explained what is absorption and emission. I'll explain you one more time. The basic principle is that it's telling that it may be due to absorption, whether the amount of light absorbed, or it can be through the emission, whether the amount of light is emitted. We'll calculate how much amount of energy is emitted, or we'll calculate how much amount of light is absorbed. By these two calculations we can determine the compound, which type of compound or which type of sample we are analyzing. This is the basic theory. I think so you understood, or else you can just see one more time. Next, these are base absorption and emission. When a molecule absorbs UV radiation of frequency, the electron in that molecule undergoes transition from the lower to a higher energy levels. As already said, it moves from the lower energy state to the higher energy state. The energy difference is given by E equals to hv. Here h is equals to Planck's constant and V equals to frequency of radiation. And to calculate the actual energy required depends upon the energy between the ground state and excited state. Here the actual formula is E1 minus E0 equals to hv. Here E1 is the excitation state and E0 is the ground state. The energy difference between these two will calculate to get the actual energy required for excitation of the electrons. Next. The energy absorbed in UV region produces change in the electronic energy of the molecule, resulting from transition of valency electrons in the molecule. Here, the energy absorbed by the molecule or the sample causes transition of electrons, transition of valency electrons. This is the main principle involved in UV spectroscopy, causes transition of electrons by the absorption of light. There are mainly three types of transition of electrons. First, sigma, pi, and non-bonding. Sigma are these type of electrons are involved in single bond compounds. A saturated single bond are saturated compound. These require highest energy, and they have highest energy and require high energy for transition of electrons. And UV light for transition. Okay, here the transition is between sigma to sigma star. Example, paraffin. Next, pi electrons. These are involved in double bond or triple bonds between atoms. They have lower energy than the sigma bonds and require lower energy the UV light for transition from pi to pi star. Did you can understand? When the energy of the required amount of light is absorbed by the molecule, if it is pi electrons, it converts to pi star. If it is sigma electrons, it converts to sigma star. Non-bonding electrons means they are not, the name only says that they are not involved in bonding. What are the electrons that are not involved in bonding? That are called as lone pairs. Lone pair are not involved in bonding. Example, if you can see in oxygen. Oxygen has lone pairs. Sulfur has lone pairs, etc. Any compound, example phosphorus has lone pairs. These are the electrons which are not involved in bonding, so they are called as non-bonding electrons. These electrons are also known as lone pair of electrons and not involved in bonding. They have the lowest energy and require lowest UV light for excitation. They are divided into two types: N type, N to pi star. It is pi means what? It is involved, the compound has compound is unsaturated. And next is sigma, N to sigma star. The compound is saturated, contain lone pair of electrons like hydrogen, oxygen, nitrogen, and sulfur, and halogens. They require less energy. They require less energy than sigma to sigma star. The strongest one is this sigma to sigma star. We'll go with I'll just show you the diagram. You can easily understand this. See, this is pi, bonding sigma, non-bonding pi, non-bonding n, anti-bonding pi star, and anti-bonding sigma star. Here, from bonding to anti-bonding, it is require highest energy. This require highest energy. The second highest energy is this one. The third is this one, and this one. N-type electrons require lowest energy. This is the decreasing order. You can see this has highest energy, this has lowest energy. That's it. The transition of electrons. It's also an important topic. They have asked questions of base on this. I have to just know the meaning of it. It's very simple topic. You can understand. You can write it on your own words. Next, the principle. Here, the principle is the main principle of UV visible spectroscopy. The principle of UV visible spectroscopy is based on the absorption of ultraviolet light or visible light by the chemical compound, which results in production of distinct spectra, and the spectra ranges from 200 to 800 nanometer. This causes the change in the electronic structure of ions and molecules. I'll just tell you how to remember the principle. It's very simple. You can remember the principle in very simply. You can remember. I'll just tell you. If any spectroscopy, it may be like visible spectroscopy, NR spectroscopy, or mass spectroscopy. The basic what here is going on, the absorption. It is based upon the light, right? Electromagnetic radiation. If we are taking UV spectroscopy, UV visible spectroscopy na, then the absorption of UV visible spectroscopy, this is the principle. If you are taking example NMR, absorption of NMR light, it is the principle. If you are taking any spectroscopy, if you are taking mass spectroscopy, absorption of mass is different. If you are taking fluorometry, etc. The basic principle, the concept is absorption of the particular region of the electromagnetic radiation. This is the basic principle of the uh, spectroscopy. If here you are taking UV visible spectroscopy, so that the UV visible spectroscopy, the absorption of ultraviolet light or visible light by the chemical compound. This is the same principle. The terms here from here. This is the term changed in the different principle. I explain the next principles in next concept. Next coming lectures, the basic what I have find the difference is that only you have to change this. This is all same. The absorption of spectroscopy, the absorption of UV visible light or visible spectroscopy by chemical compound, which results in the production of distinct spectra, and the spectra ranges from 200 to 800 nanometer. This causes change in the electronic structure of the ions and the molecules. It is limitedly used for sample identification, but are very useful for quantitative measurements. This is the basic principle and a application of the UV visible spectroscopy. Let's start with our theory. Laws of theory. First, what is Lambert's law and Beard's law? Beard's law states that the amount of light absorbed by the material is directly proportional to the concentration. It tells that the amount of light absorbed by the material is directly proportional to concentration. Here, light absorbed and concentration, it is directly relationship. Beard's law. Whereas Lambert's law tells that the amount of light absorbed is directly proportional to the thickness of the absorbing material and is independent on the intensity of incident light. That's the both Lambert's law and Beard's law. By combining these two laws, they gave Beard's Lambert's law. It is a combination. It is a combined law states that the amount of light absorbed is proportional to the concentration of absorbing substance and to the thickness of the absorbing material. You can tell the thickness of absorbing material. Sorry, I have scratched it. It is also correct. Or we can tell the path length beam through the solution. Path length. You can directly tell the path length or the thickness of the absorbing material, or we can tell the path length of beam through the solution. These two are correct. The thickness is nothing but path length. Then here A epsilon BC. Here A is absorption, epsilon is molar absorbability, B is path length and concentration. Path length is nothing but the thickness of the absorbing material. That's it. We'll go with the derivation. Sorry guys, this is my first lecture. There is no experience in teaching. I'm little bit not able to speak or tell what is in my mind. This is my first lecture, so that please adjust. I will surely improve in my upcoming lectures. Derivation based upon the theory, Beard combined law. It's given when a monochromatic light is passed through the solution containing the absorbing substance. The decrease in the intensity of light with path length is proportional to the concentration of the solution and the intensity of light. It is combined. The both Beard's law and Lambert's law, they have combined and are derived in this statement. When a monochromatic light passes through the solution containing absorbing material, it the path it is directly proportional. The intensity, the decrease in the intensity of light, is directly proportional to the concentration, how much concentration, and the concentration and intensity of light. Okay, here minus di by dl equals to concentration IC. Here I is nothing but the decrease in the intensity of light, and minus indicates that decrease. Here minus di by dl equals to k into IC. K is the constant. We are bringing a constant. We are interchanging the terms. Here intensity of light and the path length we are changing dl. Then we get minus di by I equals to k into c into dl. On integration on both sides we get integration I naught to I minus di by I equals to kc 0 to L dl. On integration we get natural log minus natural log I by I naught equals to k into cl. On interchanging the terms to remove this minus, natural log I naught by I equals to k into c into L. We know that natural log equals 2.303 log, so that we are replacing the natural log. 2.303 log I naught by I equals to k into c into L. Therefore log I naught by I equals to k divided by 2.303 into c into L. But we know that a equals to log I naught by I, and k by 2.30 equals to epsilon. So we'll get the equation. So we get the equation a equals to epsilon c into L. That's the equation of the Beard's-Lambert's law. It's very simple and very important. Any paper, most of the question papers, right, Beard's-Lambert's law are asked, and the deviation also is asked. The deviation is very simple. The deviation is divided into real deviation and chemical deviation. Real deviation is nothing but occurs when the concentration of drug is high. Did you get it? Occurs when the concentration of the drug is high. Particles are too close, affects the charge distribution and extent of absorption, causes deviation by linear relationship. Here in linear relationship, what it causes, right? This is the sample, or this is sample holding the sample holder holding the sample. If the concentration is too high, what happens now? The absorption of light, the light absorbed by these particles is not transmitted through the tube or cuvette, so that the deviation deviates. There is no linear deviation. This is the real deviation is meant by. Here, as the concentration increases, the absorption of light also increases by these particles, and these particles are not absorbed and the light does not come out, so that the light intensity decreases significantly, and there is no like proper method to overcome this, so that concentration should be minimum or balanced. Next, chemical deviation. Chemical deviation is divided into 5 types: dissociation of molecule, association of molecule, change in pH, presence of impurities, and concentration ratio. These are the 5 types. You can write on your own. Dissociation of molecule means due to increase in the dilution. What happens now? If we dilute very in microliters, now here the sample will be there. Here, if the sample is there, light passes through the cuvette like this, and there is no detection of particles, so that there is deviation. And association of molecules is due to turbidity. Causing of turbidity also causes deviation. Change in pH directly proportional to the absorption of light is directly proportional to pH, so the pH is very important. Presence of impurities. If any impurities are present in between, they may trap the light and they cause deviation. Concentration ratio. occurs when the concentration is very high or very low. These are the main deviations occurs in the Beers-Lambert's law. That's it for this video. I think the video is a little bit long. This is my first video, guys. Please adjust. From next onwards I will decrease the time so that you should not waste the time. That's it, guys. Next video we'll discuss the instrumentation. Thank you. Bye. Take care. See you in my next lecture. You can just write down in your book. You can pause the video and you can write out. I have not created any Telegram channel yet, but but later on I'll just convert it. I'll just send based upon your request. If I get more requests, I will just send my notes. Before that, you can just refer these notes. Please, guys, like, share and support my channel. This is my first channel. I have not done any channels as there is no particular channel for M pharmacy, so that I have created for making you understand it very easily, and there is no notes, so that I have created this channel. Please understand and support. Next we are going to discuss about the instrumentation. Instrumentation is very important in this UV spectroscopy.